The definition of a mean proportional is if the two means of a proportion are equal, either mean is called the mean proportional between the first and fourth terms of the proportion. In a mean proportion, there are three triangles: small, medium, and large. In this example, we will be using the small and the medium triangles. The mean in a proportion will always be the side that is shared to both triangles, or the reflexive side. Here, 8 is the reflexive side, so that is the mean. The x and the 4 are the other corresponding sides to the triangles, aka the extremes, and you will write those here. Once you have your proportion, you're halfway done. Next, you cross multiply and you'll get 4x is equal to 64. Once you have that, you can simply divide by 4 and you will get your answer. And that's your answer. It's that simple. Now that you know how to solve regular mean proportions, I will show you more complex problems and how to solve them. For this example, you want to find a specific side of the proportion. You must use the given proportion to figure out the side. Since you are given both extremes and you know that both means are equal, you can easily figure out that the missing side of the proportion is DC. That example was way too easy, so here's another more challenging example. Say you are given that side AD is equal to 3 and CD is equal to 6, and you must find DB. First, figure out what types of triangles you will use: small, medium, or large. We would use the small and medium triangles in this situation, since we know two sides of both the small, 3 and 6, and the medium, 6 and x. Next, you set up your proportion. Since 6 is your reflexive side, that is your mean, your proportion should read x over 6 is equal to 6 over 3. Then you cross multiply and solve. 3x is equal to 36. Then you divide by 3 and you get your answer, which is 12. There are three types of basic triangles. An equilateral triangle has 3 equal sides and 3 equal angles. An isosceles triangle has 2 equal sides and 2 equal base angles. A scalene triangle has no equal sides and no equal angles. In triangles, all angles add up to 180 degrees. In an equilateral triangle, each angle is 60 degrees. Other types of triangles include right triangles, obtuse triangles, and acute triangles. In a right triangle, there is one right angle. In an obtuse triangle, there is one obtuse angle. There can never be two obtuse angles in one obtuse triangle. In an acute triangle, there are 3 acute angles. With these 6 types of triangles, you can combine them to create triangles that tell you what angle is inside the triangle. Examples of these triangles are an acute angle, which includes an acute angle inside the triangle, a right triangle, which has a right triangle present inside the triangle, and an obtuse triangle, which has an obtuse triangle